right? There's a huge difference between pulling data in the form, basically raw data, into some sort of system versus having data that you can take actions on. So step number one for us is really to do exactly that, fully contextualize the data so that you can really take action based on the data so that they're insightful and meaningful. And then do some of that action taking and basically outsource it and leverage AI to assist you with that, to basically turn it into like an assistant or a co-pilot technology that also takes on some of that action taking for us. So given the vast amount of data that we have, and given the environment constraints and the production constraints and also the workforce constraints that we're under, with a lot of teams being run very lean nowadays, we need modern technology, big data technology, and AI to really make use of those data points to the maximum efficiency possible. So a few years ago, when we started with Ambyint, we actually had a pure physics focus on solving problems. The team back then, and actually myself included, have a more like a physics-focused background for multi-phase flow physics, numerical simulation, etc. So naturally, that's how we try to solve these problems. We quickly realized, though, that a lot of the data that we receive don't necessarily have the quality to run physics simulations or physics-based models exclusively. It's just a natural constraint of the data that we're working with. Given that constraint, we had to come up with different solutions. So one premise that was extremely important to me, and is very important to the company, is that the people that we're working with have potentially worked in the field, the operators and the technicians and all the engineers, for potentially decades. So they have really gathered a tremendous amount of hands-on information and knowledge and insights that we want to leverage. So our core team is really strong with physics. We have a team that consists of everything from astrophysicists to petroleum engineers to chemists and so on, that they sort of provide a perspective which is very unique to the physics problem and engineering problem that we're actually looking at. Second, we have a very strong team of subject matter experts that have themselves decades of experience working in the field, operating these different artificial lift types, interpreting the data, taking action. So they know what's needed, they know what the customer needs. Extremely important. So initially we just started combining those, but then we saw that in order to scale that out, we need that third piece, and that's AI. So AI sort of rounds up that triangle, that trifecta of different sort of approaches. But we have seen really solid and very convincing results from commercial expansions and pilots. As an example, production uplifts on the oil production side of 14 to 17%, on the gas production side of over 20%, and greenhouse gas emissions reduction due to venting reduction of over 70%. So these are actually three different cases, but that they're becoming more and more common because of that impact of automation really speaks to Ambyint also really listening to the customer and really making sure that all that feedback is incorporated, because in the end, we highly benefit from us and every customer benefits from that. It's a learning process together. The more feedback we get, the more we can implement that and the better the product gets in the end, making our customers more successful.